The next transformation is going to be very useful. We're going to learn how to make something called a tosylate. As we've mentioned several times now, the hydroxyl group is a poor leaving group. So we've seen that you can protonate it and make it into a better leaving group. And then we saw in the past two videos that you can use thionyl chloride or PBr3 and go through a different strategy to convert that OH group into a different leaving group that will leave as a weak base. Another really good leaving group is outlined in blue here. And the part that is in red is called para-toluene sulfonyl, or oftentimes abbreviated to just a tosyl group. And it's oftentimes abbreviated even further to just RO, and then TS will represent the tosyl group. We call this type of structure a tosylate. The nice thing about tosylates is that they're shelf stable. So the other reagents that we have talked about using, say for instance thionyl chloride or PBr3, they will react with the alcohol and then immediately come off as a leaving group in situ, so to speak. So as they're formed, they're being reacted. You couldn't take, for example, the species that we made before looked something like this. You couldn't take this off out of the reaction and just set it on the shelf to pull it out and use it later. It's too unstable. Tosylates, however, you can make them out of the alcohol, store them, and then react them with whatever nucleophile or whatever base you would like to use, depending on if you want to do elimination or substitution. And as I just alluded to, you can use tosylates to undergo either substitution or elimination reactions. Here's how you prepare a tosylate. You start with the alcohol that you're wanting to react, and put that in with tosyl chloride, which we'll look at in a second, and pyridine, and you will end up making the oxygen-sulfur bond. And tosyl chloride looks like this, where you have the tosyl group and then the chloride. The alcohol will reach out and grab a hold of that sulfur electrophile, and you'll see this pi bond open up, and then in a second step it closes back, displaces a chloride ion, and after the chloride ion is displaced, the pyridine will deprotonate this oxygen atom, and we will end up getting the neutral tosylate, and so this is abbreviated ROTS. A tosylate has the same reactivity as an alkyl halide, and so any reaction that we learned with alkyl halides you can also carry out with a tosylate.